conventions, you've actually reduced the complexity by a lot. Like you're putting a ceiling or on the for not necessarily putting a ceiling on it, is that you're just lowering the curve already. So the complexity is already lowered if you define conventions, so it will just be lower now. Doesn't mean you can't get any higher. By the way, that curve will still be, it's like 1 over x, if you think of it that way. 1 over x, even if you lower it, it'll still hit a point where you can pretty much go to infinity if you do it a certain way scaling. So that's kind of one way of thinking about it. But this is kind of the different design things. So when we talk about Odin, one of the most things that most people bring up, which is the most unconventional thing in Odin, is the declaration syntax. And most people seem to, this is interesting, I find this interesting. I don't understand why actually, but most people seem to judge a language's syntax based on its declaration syntax. And it's kind of weird. Like, not necessarily what you'd think. So what do I mean by that? So I've written an article about this before, but Odin's, let's say the typical thing. So if people come from C, they are used to effectively having what I call, let's call this type focused syntax. It's not technically true. Something like Java would be type focused, but C isn't technically. So let's do something close. Like for instance, hey, this is a int star x, and then we're going to do, let's just do equals 1, not equal, what am I doing? Not int star, let's just do int. Yeah, let's do int x equals 1, 2, 3. Like so. Now, C's approach here, this is, you can technically do this in a one pass, but the problem is that you still need a symbol table when you're doing it. So it's nothing to do with about one pass syntax or anything like this. So I'm sorry, some of the comments. This is the C approach, or I would call this type focus. There is qualifier focused, where qualifier focused effectively looks like this, which is kind of very similar to Pascal, or more modern would be Go, or many other languages like Rust. And many of them, this is the more popular one. Odin's approach is a little different. Odin's, I'm calling it name focused. I've written an article about this before, the aesthetics of declaration syntax, and it does this. So it changes the syntax based on the declaration. So these are all the same. Now, for variables, most people are absolutely fine with it. It's when it comes to constants or procedures specifically. So in C, you would have a void, say foo, and it takes an int, say I, and then you got the body. In the other type of syntax, you would go with, say, func or something, or proc. Let's do proc, just to be consistent. Proc, foo, I, int, and then some braces. It's really hard in a like thick font. I'm not lowering it, whatever. It's just trying to be easy on stream for people. But in the Odin approach, what we're doing here is foo, colon, proc, not pork, proc, I, int, colon, braces. Now, when people see this, they go, oh, what's the colon mean? What does this mean? And the thing is that this is actually simpler than some of the rest. And it's actually a bit more unified. And people, when you look at it, it doesn't seem like it, but it's like, once you understand what the colon means, you're like, oh, that makes perfect sense. But it's this initial weirdness, because it is unconventional in the first sense of that term, as I said. Again, the first sense is the similar to pre-existing conventions. There's not many languages that do this, really, especially for constants. Because the other approach I could have done was const foo, and then write proc, I, int. And some languages have done this, by the way. I think one of them would be Zig. But Zig is actually, interestingly, this is kind of a side note. Zig originally had more this for procedures, and then constant. All the constants had this, but they're wanting to unify to this. So effectively, they've got the same semantics as Odin. It's kind of funny, but it's like, I figured out all the problems with this as well. And Zig has figured out, had solutions to its approach now. But it's just kind of funny. I'm like, I knew what the problems were. It's like already, and I solved them, but for Odin. So it's funny how languages kind of sometimes they converge, sometimes they don't. But yeah, it's always about the different things. But semantics wise, you can technically make all of these work the same. Not necessarily this one, but you can make them all pretty much work the same. And it is very interesting. And again, some people say there's many issues with the C declarations act. One, you have to have a parse table. Another one is that C specifically, in the same as C++, is that the declaration matches its usage, which is queer as anything. It's like when people actually don't even know how it works, unless you do that, it doesn't make any sense. And yeah, sorry, you bring up a very good point, Barkow. Barkow, or how you pronounce your name. I apologize, I don't really care. Sorry. Is this, you say yes, the kind of the complexity, the size thing about code bases, which is the intersection of the horizontal and vertical scale problems, is it's very similar to compression. And it is a very interesting way about thinking about things, about programming in general, is about kind of this form of semantic compressing of code. Is that, again, if you have a big size and low complexity, it's highly compressible. But if you have something of low size but really high compressibility, it's not going to be easily compressed. And it is all about the entropy of the system, you're right. But it is a good kind of abstraction to think about. And it's also about things about language design in here, and you have to think about what I'm doing. So let's talk about some practical things about what conventions Odin has taken. Because it's not obvious what conventions I've done, especially if you're coming from C. If you're coming from other languages, you don't realize their conventions. A good example in Odin is slice types. This may sound like, wait, how is that a convention? It's like, because if you're used to C, in C, well, there's no actual real convention. In C, you've got like a pointer, and then you've got like maybe a size _t that you're passing around separately. And like these are separate things, and that's kind of like okay. And then depending on like certain conventions, they'll have the parameter, the length first, and then the pointer next, or the point. Like okay, so there's another issue is like okay, you got a pointer in C, and then you don't even know if it's a pointer to a single value, or if it's representing an array of values, or it's representing just a general memory address that's typed. Again, there's different memory models, so it's like okay, it doesn't know that. In C, it just goes like okay, we're defining what an array reference is. We are separating that from a pointer in the language, which is just that. It's pointy, and they are kind of separate constructs. And like pointers in Odin do not allow for index notation, like unlike C, where in C, if I did xi, that is identical to if I did the dereference of x plus I. That's what it does. That's all that does, effectively. Technically, some compilers do different optimizations based on this, but that's the internal details. Semantically wise, they are identical, which shows the pointer arithmetic magic going on. But Odin doesn't do that. It says, no, pointers don't have pointer arithmetic. That's another convention. That's what C had a convention with pointer arithmetic, because it traded off by not having an array type. So yes, a good way of thinking about a slice is to call them as fat pointers. That is another way of thinking about them. Yes, they are fat pointers. They're a pointer that also encodes a length to them. Another convention that Odin took is string. Odin has a string type, and C's convention is so string is actually internally a byte slice. So internally, a slice of bytes. But why has Odin, this may be a good question, I'm going to actually ask the people to the audience if you want to answer, why does Odin define a string type, and why doesn't it just have a slice of bytes? Why am I defining the convention of what a string is? It's actually a really interesting question when you think about it, because it's not obvious. Because in C, you think, well, we just have char pointers set, don't we? Have a string, so that's effectively what a string is. So why do we need a specific string type? I'm just going to have a drink whilst people will discuss amongst yourselves. Okay. Is everyone ready? Ready for the answer? It's pretty simple. It's not just about encodings. It's not because runes are variable lengths. Yes, they're all different conventions that I've defined. Like I have conventions of a string is assumed to be a UTF-8. It's because a string has different semantic information than an array of bytes. A byte is effectively just a number or a blob of information. It hasn't got the same semantics as a string. It doesn't represent text, even though it could store text. It doesn't mean it has the information, semantic information, that it is a text. Because you could say, hey, look, an integer at the end of the day is just like an array of bytes. So why don't we just use array of bytes? And the thing is, you can go that way. You can actually go that way and thinking, and then you're defining everything in terms of the operations that work on it. But then you're back to assembly. And that's one thing. So another thing, so that's kind of the thing, is that semantically it's a string. And you kind of see that strings are useful because we are dealing with a textual language at the end of the day. And also we deal with text all the time. We have string literals everywhere. So really, we do have this concept of a string type already in the language level, even though we could theoretically just have it be an array of, like, a slice of bytes. There are all the very good things that people are talking about, like the implementation details. Like, for instance, yes, you could allow for string interning rather than just relying on everything being a separate value. Yes, you can also realize that a string is actually, because it's got different encoding information, that indexing it or assigning to it it's going to have different semantics. Like, for instance, you cannot assign to a string index in Odin because they're immutable, because they've got different semantics. It's because in practice, this is one actually my side detail, but I found in practice that most C code bases, people rarely ever assign to a string index. And when they do, it's because effectively they want a string builder. They've got a backing bytes buffer, which they can use to generate the string, or if they just want to do a quick optimization, something in place. And it's like, okay, each of them isn't really a string. You've got a string builder, something you're building a string with. The second one is you've got a backing buffer, which you're modifying, so you're building a string. And then the third one is like, well, you just do some optimization hack, which is effectively a backing buffer. But this is it. None of it is actually treating it as a string. It's just you're building a string in that case. So there's a difference. So in Odin, we actually have we have a string builder in Odin, in fact. The core library string builder, let's go back to green. Let's go green this time. Strings.builder exists. And this allows you to build strings easily. Now, many people prefer using the fumped stuff. So like fumped, let's say a printf. So this allocates a string for us. And there's also the tprintf as well, which is the temporary it uses the temporary allocator instead. But these are all like kind of effectively string builders. They are not strings in themselves. They generate a string. And that's where a lot of languages I have found, this is the issue. It's like, yes, many languages have a concept of a string type, and it's because it's semantically useful. Even if internally it's the same as a slice of bytes, like internally at least, like semantically they treat it differently. Another way of thinking about it is this, that when you do fumped, I'm going to say this, but when you're dealing with this, it's fine. So I'm just trying to finish the original thought then. So many languages do seem to try and unify the concept of a string builder, and a bytes buffer. They're not the same. Like semantically not the same. It's not how you treat them are the same either. Even though this is why a lot of people love like string concatenation, because I just need to build some strings together from other strings. Like, well, you want a string builder now, effectively. So yes, it's nice and easy to do, but there's the problem: is it's nice and easy to do. It hides the cost of what it is. Now, in a lot of higher level languages which allow that, they usually have like something garbage collection or something, so they can afford to do it. Or automatic reference counting, or something general, automatic memory management in general. In Odin, when we have manual management, you want to know when things are being allocated, usually, pretty much. So you need to actually have control over that. So that's one way of thinking. So separating them is very useful. Okay, what's the second reason for strings? Well, not saying one of the other reasons, there's multiple reasons. It's not even the second. I think I've probably discussed 4 already. The other reason is for serialization. So when I go and do this, fumped dot print line and do x, whatever x is, it prints it correctly for me. If it was just a byte array, then it would be like, should this be printed out as numbers or should it be printed out as characters? It doesn't know. Or should it be like, oh, this is actually a multi-encoding thing? So if it was a byte array, it doesn't know. Now, the argument that many people say is, no, what you meant to do is actually give the formatting to it and then does it correctly. So many people will say, actually, the way like CMET languages would do it instead of this, what you should be doing is doing fumt.printf, doing, I don't know, %s \n. Really hard to write code like that, and do that way in the formatting approach. So you tell the thing how to format it. But here's the thing. Automatic serialization, because it knows all the runtime type information already, is a hell of a lot more useful. And again, it's semantically different. So this is one of the conventions again. This is again the convention setting in Odin. And it's very interesting where you're defining these conventions. Which, one of the big conventions, which many people seem to not misunderstand. Yeah, they misunderstand it, to be honest with you. And I see many people who misunderstand this. And some people see me on the Discord having like a mini rant over this in general, but it's not necessarily. It's hard to explain. So let's go over. Let's just go over here. I'm trying to talk and I need to have a drink because I've got the lemonade. Lovely lemonade. You're right, it's also meant to have information of the compiler. Yes, I just didn't see that. So there's many technical reasons to have strings over just bytes arrays, array of bytes, but it's also because it's semantically different and it helps with the serialization, runtime information, compiler reading the code, the human reading the code, and so on and so forth. So this leads up to another convention, the convention of packages as a convention. Now, I use the word package, library, module usually interchangeably because I just use it to mean a group. It's pretty much a collection of code which then can be reused elsewhere as a single unit. That's effectively what a library is, or a package, or a module, whatever. It's not a collection of multiple of those libraries, which I used to call them a library collection, or a collection of packages, or whatever. So this is an interesting problem. So most people who design languages in general, most people who use languages, understand the benefits of namespacing. So most languages, let's say ignoring C, for example, have some concept of a namespace which is separate from the body of like a procedure or a type itself. They can do other namespacing. Now, but the thing is, what do you do with the namespace and why is it useful? Well, first off, it reproduces namespace collisions is a good thing. So there's one aspect of packages. So you've got namespaces, like so. Another one is the interface to it. Another aspect to packages you've also got to worry about is dependencies. Sorry, I couldn't spell today. Other aspects between that is it's reusability, usability. Another one is for organization. By the way, these are all different separate points. I'm trying to think of other information regarding packages right now. There's one more I know. Another one is containment, which is slightly different to organization, but containment. So theoretically, a generic namespace, let's say like C++'s namespace, allows for organization, containment, even reusability to a certain extent, but it doesn't tell you an interface. It doesn't tell you about dependencies. So, okay, we could do what Python does. Okay, let's think of the Python approach then. Okay, so the file is a namespace. And in fact, you can import a file. So, okay, so the file thing gives us namespaces. It gives us effectively an interface, which is the interface, a namespace itself. It does give you a dependency because its dependency is now part of the file system. So you can have a hierarchy, file system, and many other things like this, stuff like that. It doesn't mean you can reuse things, you can multiple import, it does help with organization, and it does things containment. So it does actually solve a bunch of these problems. But here's the thing, is ask yourself, Is that well defined? There's the problem. How do you well define a package? Because there's extra things related to all of this. Like, for instance, one thing is versioning you've got to worry about. And these are I would call these the extra things which are required, but they're not necessarily well defined. You've also got to worry about is structure of your package structure. And then another aspect is, again, it's these are the secondary things or the tertiary things, I'm not sure which one is, regarding how you deal with these. Import graph, and I'll call it a graph, which then leads onto cycles. But there's many different things on here as well, and it does get very difficult about how you deal with these things. And there's many languages that really do not solve this problem, because the problem is what happens with all of these things and the consequences of how you do the design decisions. So most people completely understand namespaces. They understand why you want to have different namespaces, because you don't want to have name collisions. So this is collisions and locality to it all. So there is this kind of issue of the locality, because when you've got things, they should have to worry about the namespace collisions. You don't have to work in your code, and then anyone else have to worry with C. You've got a global namespace. You're going to have to do things. Again, C is just treats it as one giant file. That's effectively what a thing is. So there's no real concept of a package. C++ has no real concept of a package either. Yes, it has namespaces. It doesn't really have an interface. It doesn't really have any way of doing the dependencies. It doesn't know about dependencies. It helps reorganization. It does organization, which is with the namespaces in general. It doesn't really do any containment, because everything's global space, even if there's multiple namespaces. It has no idea about versioning, and it doesn't really enforce the structure. So it doesn't meet the requirements of what a package is. Let's try Python again. Let's look at a Python. Yes, it has namespaces. Does it have an interface? Well, everything is just in there. So yeah, everything's public. So technically this is public versus private. And this is the module level, by the way, package level. Dependencies, yes, because due to the import graph, it has it. Yes, and also it allows for cycles. Reusability, well, yep, it allows for reusability because it does, because you allow imports, fine. Yes, it allows for organization because it exploits the file system. So this is also related to that point. Containment, yes, it's now related to the, guess what, the file system. Versioning, yes, it technically does have versioning, but that's usually extra metadata. And structure, yes, it's relying on the file system, the explicitly file hierarchy in that case. So, okay, Python does have it does have packages. The thing it struggles on is probably the versioning, but that's done through external conventions. So there is no language level. Language level versus tooling. And that's a good question. Even Odin doesn't have this yet. I already know how to do it, by the way. But dependencies also is technically implicit for how you deal with things. So it doesn't actually know it technically. So technically, Python doesn't have technically a well-defined package either. In the language level, it has it in the tooling level, like pip, but that's about it. Other things with packaging, you can also technically, there's like tertiary. There are tertiary things, like for instance ABI and stuff, but let's ignore them for the time being. Let's take Go. Let's take the most recent versions of Go, to be honest with you. Does it have namespacing? Yes. Does it have an interface? Yes, with public and private. Does it have dependencies? Yes, it now with the Go mod stuff. Does it allow reusability? Yes. Organization? Yes. At the language level, by the way. Containment? Yes. Versioning? Yes. Structure? Yes. So Go actually has a full-on definition of what I would class as a package. Let's check with Odin. We'll see what Odin makes up. Yes. Namespaces? Yes. Interface? Yes. Dependencies? At the language level? Technically, yes. Reusability, yes. Organization, yeah, a lot more. Containment, yes. Versioning, no, this is not there yet, but I know I would know how to do it. I've just not needed it yet because it's not actually become a big issue yet. Structure, yes. Odin deals with collisions and locality, in fact allows nesting fine. The way it deals with the hierarchy, is it going to be flat? or deep. And Odin settles for the flat problem. It says it tries not to have any hierarchies anywhere else. There's effectively no like sub packages or anything like that. Everything is pretty flat. Yes, the file system is used for organization and containment, and that is a hierarchy that you already need. There is no different levels. What about import graphs? Yes, Odin does not allow for cycles, so that's pretty good. What about versioning? Yeah, and then structure, yes. So Odin nearly fits perfectly the well-defined package. So let's say versioning, it just misses on versioning effectively and partially on dependencies. Like not much on dependencies, like only one aspect because of the versioning. That's all it fails on. It's because of versioning. But that's because I haven't defined it at language level yet. I know how to do it. We just need to have a little bit of extra metadata and problem solved. Like literally, it's bad at it. Okay, let's look at, let's think of another modern language. Rust. Let's try Rust. Does it have namespaces? Yes. Does it have a names interface? Yes. Does it wonder about dependencies? At the language level, what do you think? No, it does it by convention because of Crate does it with an metadata file. So technically no, but it's because Crate is pretty much the only package manager. Then yeah, let's say halfway. Let's say give it half point. Reusability, yes. Organization, yes. Containment, yes. Versioning, again, it's not part of technical language, but it's a very big convention anyway. And it has technically with many of the attribute stuff, so I don't want to go wrong there. And structure, yeah. So it nearly has got well defined, but it technically is mostly well defined. So Rust is no problem. What's another modern language I'm trying to think of? Let's try Zig. Zig has namespaces, yes. I'll explain how they work in a minute. Interface, yes. Dependencies, not at the language level because it doesn't have no versioning. Does reusability, technically yes. It does allow for cycles, yes. Organization, yes, but I'm going to explain. Technically, it relies in the file system. It's not part of the level. So technically, yeah, kind of containment, yeah. Structure, yeah. So this is okay. This is Zig's weird thing. So I've been talking about namespaces as if they're a separate construct. Zig unifies namespaces with types. So types have namespaces. So they are the things that have namespaces. That's the idea in Zig. And that means a file in Zig is actually a struct. I'm not joking. A file is a struct in Zig. I think this is kind of insane because to me they are semantically different constructs. Even though something like C++, you can treat a struct as if it was a namespace. But clearly C++ added another construct, which was a namespace. Like a separate construct. Because there's clearly a difference between